This conference will.
All right, let me share this. So last week we ended roundabout here on this topic, the interaction between RTU and RTREC. I think, yeah, this section here currently tightly couples them, and I think there was uh, some work left to flesh out how exactly we relate one to the other. We were talking about the RTU, like I believe we were characterizing RTU as the entity which decides can an image end up in Flash, but then our RTREC decides which one boots. Um, but if we want to do things like image reconciliation, where we write an image to Flash, it boots, and if it crashes, we revert back to the old half. But if it boots, we have the old half copy the new half, so now we have two halves in Flash. That's not globally necessary. If you can be recovered, then you may not need to have two images in Flash. But if you cannot easily be recovered, then it behooves to make sure that there can be multiple images. So considering, let's try and tie it to hardware, like a concrete instance. So let's say there's a device like an accelerator, and it has some persistent flash within it, and it can be updated by way of the BMC. Uh, if that device does not support the OCP recovery spec, and the OCP recovery spec is intended to be your get out of jail card for if everything's hosed, there is no valid data in Flash at all. If you don't have that, then we rely on some valid code within the device to always be there. Now, that could be a golden image, like an immutable image, which always knows how to uh, recover itself. If it's not an immutable image, then we'll need uh, an AB-like scheme. So we could go through these. Like we could set up a tree, like a decision tree. Like, do you support flashless boot? Do you support OCP recovery? Do you support a golden image? If none of the above, then we need an AB scheme. Thoughts?
What are the requirements for, I mean, part of that depends on, this is an OCP requirement doc. What does OCP require of various devices?
Mm-hmm.
Because if OCP in a different doc is saying, hey, your NIC must support recovery, you don't need to think through this very deeply. You can just say, because NICs must support recovery, they don't have to do AB.
True. Okay.
Now, vendors may want to do things above and beyond the requirement if they are trying to build one product that can be deployed in different markets. But I think OCP can pretty tightly narrow down what it actually needs from different devices.
All right. So let's say, and I don't know off the top of my head where we have that written down, but let's say we do have it written down somewhere. You must support recovery, and we define recovery as all mutable storage on the device is blank, and you can still boot from something off device.
So
I thought we had a recovery document, don't we?
I believe we do have a recovery document. Or no, is that framed as a you must do this, or here's how this is done? I can't recall.
Well, it should be, right? And it should be a matter of us just saying, go to a recovery document and do one of the things that are
Okay.
required there.
All right. So this is scope.
There's a spec. Is there actually like a requirements list for different components on the platform? Right, like there's an OCP recovery spec, but that I don't think the spec itself dictates which devices or components must implement it.
Creates guidelines on how to recover a failed or compromised device. Recovery operation provides a mechanism to recover device's firmware. Recovery must bring the device to a known security state. The device is expected to conform to the OCP secure boot document. This includes all images, including recovery. Use cases, roles, recovery image. This looks like this is kind of treating the PA rod as load bearing here. Does this mention the word BMC? No, no BMCs here.
Yeah, I don't think it describes an architecture, but like it doesn't describe a platform architecture. But I think it describes device capability in terms of a immutable anchor for recovery. Um, and it's probably changed since I last read it, but it had some I2C recovery mechanism.
Yeah, it does describe I2C.
Yeah, and I believe occurs from device ROM. And it probably doesn't say ROM, it probably says like a mutable anchor.
Got a lot of noise.
Recovery yeah, the one area, the kind of gray area that I have, I recall there was an open on whether the recovery is forced from like an external entity or pin on the device, or whether the device autonomously decides that it should enter recovery. And I can't recall which way the spec went on that.
Or when forced to recover. Or the PA rod can force recovery if permitted. Looks like it leaves it up to, it's not defined in this document whether it's a force or not.
Yeah, and it should probably read, like for consistency, it should probably be not like PA Roth, but like RT Rec.
Mm-hmm.
Is probably a better way to describe it.
Some external agent, it does not need to be a PA rod as like a microcontroller.
Yeah, exactly.
Okay.
Jeff, there is another thing at some point we need to think through is NIST 193 allows to recover using root of trust for recovery or chain of trust for recovery. So I don't know whether we want to allow chain of trust for recovery, but something to consider. 193 allows that. You don't have to recover from the root of trust for recovery. You can use something already part of the chain to recover.
Yeah, and the difference there being that it doesn't have to have a I guess a tap all the way back to the to RT rec, but it can be a multiple hops in the chain.
Section 4.1.4, or maybe other places as well, but I was just searching for CT rec. We have some information there.
It's worth noting 193 is a platform centric document, and we're currently talking about like device centric capabilities. So from the point of
Agree.
view of the platform, the device recovery agent is part of a chain of trust, not a root.
I think some of these concept also applies to devices. Device can also have a chain of trust recovery, right? If somebody chooses to implement.
Right. If the device has multiple stages in order to recovery, then it would have a chain.
Right.
But I think the point of the OCP recovery doc is you must have a way to get back to functioning if your entire storage is corrupted.
Agree. But in the complex IO adapters may look similar to server, for example. It may have multiple stages of firmware and chain of trust and all those. That's what I was thinking about. I think simple device, you are right, Matt. It may be just recovering to non-good image, but for complex devices, it may look very similar to the platform level recovery.
Yeah, at a system level, the way the spec is it's probably going to be difficult to get consistency. Like I think the basic is there where device must have some bare metal recovery. But bare metal meaning it doesn't need mutable code on it to get this recovery working. But what does that mean from a system level? Does that mean that you need to always have a recovery image come in from somewhere for this device because it might decide by itself that it needs to enter recovery? Or from a system level, is there a way to invoke device recovery? That's not clear from the specification. And if you look at the state of devices today, recovery is the forgotten security property that's kind of massively inconsistent in how devices can be restored to a functional state when they become either compromised or just inoperable. Everybody has an idea of how it should work, but those don't necessarily align to provide a implementable RT rec.
Yeah, I kind of feel like the system invoked recovery capability is a requirement. Whereas the autonomous stuff is definitely nice to have. But I think Brian's bringing up a really good point, which is that there are two perspectives on on recovery, right? The sort of device's perspective and the system's perspective. And I think it's important that the system perspective always supersede, right? The reason I think that is at some point it's, some system entity's job to orchestrate the rest of the system. We kind of have that concept in the PA rot. And at a certain point, the system might decide that a given device isn't functioning correctly or isn't providing the sorts of communication that the rest of the system expects, and there should be some way to tell that device to fix itself.
Mm-hmm.
Now, whether that fixing can happen autonomously or not, I think that's a separate question. But certainly, you want to have some way for the system to invoke that recovery capability.
I think if someone comes in and says, "Hey, I'm the system and I want to recover you because I think you're misbehaving," the device might not think it's misbehaving, but that doesn't matter. The device is like, "Okay, the platform really should be able to force me into recovery," and in that case, the device may still want to, you know, have it all pass through its own RTU. So you can force it into recovery, but you cannot force it to take an unsigned image.
Exactly. Yeah.
Yes,
Yeah.
absolutely. Uh, so here, excuse me, just had to ask. Uh, do we take the order of uh, uh, precedence in the way, if we see a signed image has failed its validation, then so we would have a separate copy of the image stored in the same active slot. So do uh, so does first the device need to autonomously use the redundant copy and try to boot uh, out of that? So that'll be the first, and if not, then it will be, say, over a sideband interface, tell a host that the active slot has failed to boot out of due to signature mismatch, and now we have two options: either you ask the device to enter into a recovery mode, um, and we go into a mode, say, where we initiate SMBus, or even, SMBus has to be active to be able to talk to host over sideband, and we accept a recovery image. So that download is accepted, validated, and try to boot out of. Or the other alternative, that the device asks the host that, shall I uh, switch over to the um, backup dormant slot that may have two more redundant images, or two other images maybe of the same version or not.
So that's a good question, and I actually kind of I like what Matt said earlier, which is if we scope this to OCP devices, like the vendors may well wish to go above and beyond and satisfy other markets and other requirements, but if they satisfy the OCP recovery requirements, as in the device can be recovered if it's gone bad, then do we even need to say anything about redundant images in this specification?
I don't think so. It would be my opinion. I think it's good. Like redundant images is kind of a reliability nice to have from a device perspective, but it it doesn't provide robust recovery.
Mm-hmm. Now, okay, let's consider, just while we're riffing on this, uh, let's say the device we're talking about is the BMC. Um, that thing, and let's also assume that its own recovery path involves, like, you know, well, let's say it doesn't have a recovery path, right? Like the BMC needs to be up because that is the root of trust of recovery for the entire platform. Let's assume. So if that is the case, and it is the root of trust for recovery, it doesn't have anything to recover it, then we wouldn't be able to just assume, oh, just get yourself recovered.
Yeah,
Yeah.
that's a good point. On the BMC front, like you're absolutely right. With it kind of becomes this this point where it doesn't have the same level of recovery as everything else. Um, I know in our system designs we look to add some belt and suspenders to that to keep it available. And I've talked about these before at OCP like a long time ago, where we kind of network boot the BMC like just all of the time, and it either gets an image or it doesn't get an image, and it of course authenticates the image, whatever it gets, measures and authenticates. The thing is, BMC ROMs don't necessarily just network boot straight out of the bat, so there is a mutable code there that facilitates that perpetual network boot. A network boot either just points it, times out and drops, or points it to internal flash if it has an internal flash image, or it gives it a network-based image. So it provides some resilience, and then our PA Roth squirrels away that that U-boot image, and then the PA Roth is recoverable through the BMC. So it's kind of like a circular dependency between those that roots back to having a functional BMC as kind of a minimum requirement, but there's some additional resilience added to make the BMC always functional.
I think whatever's at the root of your system orchestration of management and security is a special case, right? And I think that's kind of what Brian was also calling out. Everything downstream of that can play by a different set of rules. But whatever's at the root, whether it's a BMC or something else, has to be available. It needs additional, or it has, it needs to meet additional requirements. I think, like Brian was saying, in terms of, belt and suspenders. Um, but it is to me a special case, right? It's a case of its own.
But platform level root of trust also have to support almost all of the device level requirement as well, because it is one of the device with additional responsibility, right?
That's fair, yeah. But if the root of um, your tree goes down, you have bigger problems um, than whether or not it's meeting some of those requirements, right? What I guess what I'm suggesting is the roots need to be built in a way that they don't go down. And when they do, it's an extremely exceptional case. There's probably something larger afoot.
Yeah, agree up to some extent, but if you treat every one of these as devices, let's say BMC happens to be root, and if it satisfies the device level requirements, potentially we can recover the BMC along the line what Brian was saying. I think there are ways you can recover BMC as well, and once you recover, then your whole entire system is back to the normal state, right? That point onwards, any device needs recovery, the platform level recovery entity can help, in this case BMC. Where I'm trying to get to is, I think it's very important to figure out what every device including BMC need to satisfy with respect to recovery. Once we figure that out, we may have to go and add some incremental requirements to the platform level entity saying that, by the way, you support these device requirements and also these additional 3 requirements to satisfy the platform level recovery requirements. That's the way I'm looking at.
Yeah, I think that's reasonable. I wouldn't expect every device in a system to meet the same requirements I would expect of my BMC though.
Right, agree.
I
I
think
think it
the
depends on
BMC
the
is like a
capability.
superset, right?
Right. I
Uh,
think that's where NIST 193 also had a lot of challenges. The picture that Jeff is showing was a result of those things, right? Like there are different devices. Some of them may not even be able to recover by themselves. They need help from other devices. All sorts of categories of devices we have. I think key thing is to understand what minimum requirements we want to put it on different kind of devices that we find in the infrastructure components, infrastructure products rather.
Okay, so the current document that we're noodling on, being the root of trust for update requirements, is currently scoped to a device, and I think that right we can't mandate every device can recover itself over I2C. Because every device doesn't have someone to recover it over I2C. Most of them do, but there are these special cases. So should we say that? And I think you're right. We do need to take a look from a platform perspective, make sure everything's consistent. But from the device's perspective, this particular document, do we do a decision tree here and just say if you are a device that can be recovered, subscript should be most all devices, then well, then what? Like,
External support.
we can say you must support. All right, here's the question. What do we want to mandate for a device like a BMC, which actually is at the top of the tree? If we cannot mandate that it can be recovered the same way any other device can, the property we want is resiliency. Do we want to mandate a certain approach to resiliency, like redundant images within its that are managed by its RTU?
Autonomous requirement.
Or do we want to be a bit less prescriptive?
So I was thinking that maybe we want to be a little more generic, right? In terms of saying, well, there's this special device in the platform, the root device, and it has to be able to recover on its own pretty much, right? And having AV images is one way of doing it. Having the ability to boot from the network, as Brian was describing, is another, right? But the important part is that it cannot rely on some other device in the platform to help it.
Okay. I think uh, opening bid, let's see what we think about this. For a BMC that boots from the network, we could consider the network boot as just additional functionality that the device provides, and from the perspective of getting yourself off the starting line, we have requirements over the mutable code. Like if there's mutable code within the device, which must be functional for the device to be functional, then we need redundancy over that mutable code. Whether that mutable code is a small shim layer that just goes and calls out to the network for its image, we may not need to prescribe the behavior of that code. Brian, thoughts? Because you kind of brought up the notion of network booted BMCs.
Yeah, no, I agree with you on that. You know, the network boot, like the perpetual network boot, was a kind of a means to an end to make sure that that thing was resilient. But I think it kind of goes beyond the scope of maybe the it's a very custom flow, so it goes beyond maybe the scope of like, hey, what other it's custom to like that BMC implementation. Um, it goes beyond the scope of like what devices here would really specify what they think in this spec.
Okay. So in that case, we can talk about what if we focus on the properties we want? Like if under the hood, the device wants to satisfy the properties by having redundant images that are managed independently and updated by the RTU, that's cool. But from the outside, that can be a black box. And what the properties we want, let me go to the RTU document. We think of roughly this.
That is reasonable. I'm wondering about the third bullet.
Yeah,
And
I'm wondering if if it needs to be there.
if it's needed. Yeah, I specifically was thinking, are there cases where you want to do an update to a backup image, for example?
You want to update the backup image, but not update the functional image?
Yeah.
I would. So that makes sense. I'm wondering if we can consider the only reason you would ever be updating the backup image is because the device supports backup images, and we are not mandating the device supports backup images. So if it does support that, that's kind of like the extra functionality that the device could expose. But if we're not going to mandate the device supports backup functions, do we need to describe that? It's just like another command the device supports on top of this stuff.
Right. All I was saying is that the third bullet could conflict with this, right? Kind of put restrictions on how you do this backup images and that kind of stuff. And I don't know if that's what we want to do.
Yeah, that's true. So I guess we don't want to say on any update.
Yeah, I don't know if we have to make a statement as to whether or not the thing that is updated has to become the default image. But the question is, do we gain anything by that, by saying that,
Yeah, we could
or
just not.
prevent the, yeah.
Less is more. Looks like we lost Matt. It's fine. I'll circle back with him after this meeting. Thanks for that feedback. Anyone else have thoughts on this?
So, Jeff, are you thinking one spec here to kind of capture the RTU and RT-REC requirements?
I think so, because we're going to have requirements that are not related to whether you have resilient backup images, such as rollback, or rather anti-rollback.
You know, they're always it's always two topics that are so tightly coupled they're hard to separate.
Mm-hmm.
You know, there's so much overlap.
Yeah. So I think I'm thinking right now that the only place they diverge, like whether you are a root device or a peripheral device, is whether we require extra resiliency over single points of failure. Because if you are not the RT-REC device, then that means you can be wrecked, recovered, or wrecked and then recovered. So we don't need to be as prescriptive about you must, in fact you can support rather you can be exposed to single points of failure if you can be recovered to fix yourself from these failures.
Yeah, but it's an enhancement by reducing that single point of failure down to, one entity in a system or platform.
Yeah, so I'm sorry, if I'm a device, I guess the point of this right now is, and we're of course not settled on this, but the thinking here in this being spec or scoped to RT-REC devices is that if I'm a device and I'm a peripheral and I have a recovery path, is it okay for me to just have a single image inside my persistent storage? And if it gets broke, I'll get recovered. That's not acceptable for something like a BMC. But if you have like an I2C recovery line, do we need to require more resiliency beyond what you get by being recoverable? I mean, the whole device ends up being, or rather, the whole platform, I think, I feel like it ends up being a bit more resilient if we do have this resiliency spread out throughout all the devices. but that does increase complexity. And do we need to require that? Is the question.
I think we need to require at the platform level that there may be mechanisms for recovering all devices. Some
Yes.
of these mechanisms may be inside the device, may be autonomous, and some devices may require external help. Right? They all should be recoverable, though, in one of the two ways.
I agree with Alberto. There are always going to be some devices on the platform that, for a variety of reasons, will not have the autonomous recovery capability. I think it's perfectly fine for some devices to declare that they need to be recovered by a system entity and that they do not handle that recovery themselves. That said, whatever that recovery mechanism is, has to be 100% implementable by that system entity, meaning that the system entity shouldn't rely on anything else to be able to affect that recovery. The other interesting point that someone brought up was rollback protection, right? In many cases, the system is going to have a policy for what versions you can roll back to. So we get into questions of, do we trust the device to have some sort of policy engine that can, handle satisfying, just recovering to the correct version without, help from the rest of the system. I don't know that the answer to that question. I'm just kind of bringing it up.
Sure. Yeah. What the question that begs is, I think, could enforcement of anti-rollback policies be centralized to some entity within the platform?
Right. Yeah.
Because I think typically what the implementations we see are each device has its own persistent counters based in fuses or flash, and the enforcement's kind of scattered throughout the platform.
Right. And that, that assumes that the system will always be tracking what minimum security version it can roll back to when necessary, right? Because I don't think in the case that the device is hosed, we'll have much of a chance of asking the device what its policy is, right? So
Yes.
there's either two ways that happens, right? Either the rollback policy is persistent and we don't have a way to ask the device, or the rollback policy itself is mutable and we lose it when the device gets wrecked.
Mm-hmm. And I think we should not. Well, yeah, I don't know how I feel about allowing a recovery action to reset your anti-rollback counters. And I don't think that's physically
Right.
possible in many integrations or implementations.
It's right. In some implementations, that's true. It's not, right. But yet, it's sort of a matter of device implementation, right? So if we have some, maybe it's already documented that we have a policy that says, your rollback metadata has to be, immutable or something, right?
I'm not aware of any such document we have.
Okay. But it's an interesting question, right?
Mm-hmm. I think I don't know if we can require. Well, let's see. I guess what I'm saying is, if I'm a device vendor and I have like some anti-rollback capabilities, I don't know if I'd feel comfortable giving those up and just trusting someone else to enforce my own
Right.
anti-rollback.
Right. But again, it it depends on the device, right? What do we do for devices that don't have rollback, um, or the vendor chooses to implement them in a volatile way?
Mm-hmm.
It may not be ideal, right? I I understand that we don't want to use devices like that, but sometimes we don't have a choice, right?
Mm-hmm. Mm-hmm. Okay, so I think I will leave a comment here saying that. Okay, cool. I captured that. Okay, so Alberto, I just want to put a pin in this bit here. So you had a comment about some devices can autonomously recover and some cannot, and we need to make sure that this all looks consistent from a platform perspective.
Right. I think that the requirement at the high level is that devices must support recovery, and that recovery can be either the device autonomously recovers, right, which is a lot of the devices can do that, or the device requires help from some other entity in the platform for doing recovery, right?
And
And if you're in that second category, then that puts some requirements. The platform architect has to figure out how to put that platform together so that it's able to support recovery of those devices.
now, when you say autonomous, because I think autonomous recovery might have two different definitions. I want to make sure we're clear. So one definition could be I'm a device and I know that I'm not functional, so I'm going to go reach out over I2C and ask someone for a recovery image, versus what I think you were meaning was I'm a device, I'm non-functional, I'm going to fix myself using my backup image.
Yeah, I think what I meant, and maybe that's, yeah, autonomous may be the wrong word for this. What I meant is that most of the recovery logic is in the device itself, right? That doesn't mean that it doesn't, that doesn't necessarily mean that it gets executed without some sort of coordination with the platform or anything like that, right? It just means that most of the stuff happens internally in that device once the recovery gets initiated, right? In the other case, is like, no, the device doesn't know how to do anything. Something outside has to come
Okay.
and start the process and then do part of the process.
Interesting. In both of these flows that you're describing, does the actual like image, because like I'm in recovery because I don't have a good image, right? So I need a better image. In both of those flows you're talking about, is that image coming from outside the device?
And the image could be I want it to be generic, so it could be in the device. You could have an AB image. That's one way to recover that. Or you have a little piece of code that maybe is immutable that allows you to fetch a new image from somewhere else, right? Or allows you a remote entity to give you an image, right? Or anything in between, right? Or the image is entirely controlled by something else outside of that device, right?
Okay.
The device just goes to a certain storage and picks up an image, and maybe the checking and everything else, verification of integrity and so on, is done externally.
Mm-hmm.
So here, I would just like to add that uh, 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 when we architected this recovery for our device, so the questions that came to our mind were, especially on the host orchestrated recovery, were two. First, that we may not have the autonomy to autonomously switch over to the dormant or redundant uh, slot in the spinor, since that control would have to be with the host or the uh, platform, since that uh, that the other dormant slot may have different uh, uh, versions of the firmware images, and the host may not intend to run those. So hence that direction needs to come out of the host, that that is the device even allowed to switch over to the dormant slot. So each of those active and dormant slots have two redundant images each. So overall, we have at least four firmware images in those slots. And if autonomously, if the first two fail, say in the active slot we have two copies, if both of them fail, then we look to the host that now you tell us, do you want to allow us to switch over to the two copies of the dormant slot. So either that, or the second question, do you want to download a recovery image, and we try to boot out of that, and then copy it over after validating it, then copy it over to the active slot.
I see. So so the device has a backup image, but it
Yes.
asks permission from someone else whether to use it or to get a better image.
Right. Since I mean, I think we did look at the specs also, the recovery spec, and um I think it was said that the host needs to be fully in control. So that decision cannot be taken autonomously, since the versions may be different. It may have the backup slot with its two redundant images may be at an older firmware version that the
Hmm.
platform may not want us to move to.
Okay. I have a thought here, and I'm wondering if so these flows um, where the device knows that something's wrong and it quote unquote recovers itself by autonomously booting a backup image that's stored internally and doesn't ask anyone else permission, doesn't reach out for directives or images. I think we can just not call that recovery. That's just the device being resilient and satisfying these requirements. Recovery, wondering if we can scope that to, that's where the device can't boot and needs to ask for help from someone else. That can be either, I don't have a backup image, please give me one, or it could be what was just described where, hey, I might have a backup image, but I'm not sure if it's new enough for you, so please either tell me to boot it or give me a better one. That, I think, also counts as recovery. Um,
So
what?
you're defining recovery as requiring external help?
Yes. Which I feel like that's consistent with the recovery document and other specs we put out. If it's not, then we can retool that. But that was the sense I got, was that recovery is all about, I need to go do something. I need to do something with some wires, right? Go ask over I2C or do flashless boot.
So the interesting thing is, if a device is booting, right, and it can't boot, and then it goes autonomously to a different image that it controls,
Mm-hmm.
right? Is this something that is interesting to the platform to know, right? Or is it something like the platform never knows which image this device is booting, right? Or the fact that one of the images is damaged, or that kind of stuff.
It sounds, just off the top of my head, I feel like that should be a diagnostic signal. Like, hey, I had to fall back to an image, to my backup image, and I currently only have one valid image inside me. So please fix me if you want to, like, rather, I can boot by myself, but I think I need a better image to supplement my own resiliency properties. Maybe that could be that might be something that drags us into the realm of, I need someone else's help, not to boot, but to become more resilient, or rather
And I
as
think
resilient.
I think in the case where you have multiple slots you can boot out of, but it's also fair to think that that data should somehow be manifested in an attestation, right? Um, I think absolutely the system wants to know, hey, I normally boot from slot one, but this time I booted from slot three for some reason, right? And maybe that is a diagnostic signal, but I think it is important also to the notion of understanding the security posture of the system.
So,
Right. Oh, I'm sorry. Go ahead.
well, I'm not quite sure about putting the active slot in an attestation statement, only because there's no way for that to show up in any kind of like manifest you get from like the vendor might
That's
say,
fair. Yeah.
yeah.
Uh, in some sense, though, it does seem like you want some way to get that information with assurance. And if it's not exactly in an attestation, then maybe there's some other way to do it.
And yeah, I think certainly like a diagnostic signal makes a lot of sense, whether it be like signed with a root of trust for measurement and put into a DICE cert chain or an SPDM statement, you know, don't know.
Okay. Yeah. Fair
So,
enough.
so going back to this type of devices, what I'm trying to figure out is if the device does an autonomous recovery because it found some other image that it has internally and so on, do we want to officially make notification that this happened uh, part of this recovery uh, document or mechanisms that we're talking about, right? Meaning we don't want a device to just change the stuff and not tell us, right? Use one image, switch to the next one, and then you don't know. Do you want it to require this to be part of the notification? It has to be official, and does it have to be the same, done the same way by all devices, right? Or do we just say, well, it has to be some mechanism for doing this, and it's up to the platform to decide or to what kind of mechanism to use? But the fact that the platform must be notified is a requirement.
So, okay, as I type this out, right, uh, it occurs to me if I am a device and let's say I'm a device vendor, right? I want to engineer this resiliency into me, and so I have fallback images. If and let's say I get updated, right, and I update one of the active image, and I find it doesn't boot properly, so I fall back to the old one. I can also, in addition to autonomously falling back to the old image, I can autonomously unify the two images and say, okay, like I always need to have a pair of images. I'm just going to copy the old image into the new bank. And now I have a pair of the same image. It's the old image, but it's the same, ergo I'm resilient. And the diagnostic signal I report is just tried to update, failed. And maybe that's okay.
So in those kind of cases, you have to be careful because even though there is some goodness in the uptime that you get out of that sort of automatic recovery feature, if that other slot has actively been attacked, you no longer have the forensic evidence, right? Because
Yes.
you just wiped it out by making sure that the two were always in sync. Um, so that may not be a huge concern for some folks, but I suspect it is for others.
Hmm.
Yeah, I think I mean, that's a very important case, right? But I think there may be others. It goes to if you want to have full control over what images are running on all of your devices in your platform, right? And knowing exactly what's running at any time. Uh, this sort of autonomous, let's call it autonomous quiet recovery is potentially a problem.
I actually just realized we're over time. Sorry, everyone. I got lost track of it. We had such a great discussion. So thanks. I'll capture that. We will resume. Thank you, everyone, for the contributions. We can. I don't think we have a topic assigned for next week, so we can resume discussion here. If that changes, we'll let y'all know.